Hello everyone, welcome again. Today we are going to learn about a vulnerability which belongs to the NFC. It is network file system, a network services. It's a network service and it has a really good vulnerability to exploit it. Anyway, let's start with enumerating our target. I'm gonna use this script to show this script to see which files are shared, and script name is NFC show mount. Okay, let's do it now. Okay, as you can see in this IP address there are three ports open, but the ports are in top 1000 ports, so maybe you want to scan all of the ports, but for me it's not necessary to do it here. I'm gonna just use the default port range anyway. And here, as we can see, there are three ports open. One of them is for SSH, second is for RPC, which is remote procedure call, and the last one is NFC. Here we can see our network service. This is network file system, but the file is showed under this services, under this service, which is RPC byte. But why? It's because let me explain it to all process. The nmap NFC show mount script is used to determine which files are shared by a server. Okay, and this IP address means to our NFC server. And this script scans RPC services using port 111 to identify the files shared by NFC. Therefore, it's normal for nmap to show files being accessed through the RPC service on port 111 because NFC operates under this structure. What I mean is, while port 2049 is used for actual file transfer and access, this port is utilized for RPC communication. Okay, so NFC works like that. This is for files and access, but this is how we communicate with the files actually. What I mean by this, I mean this RPC, it means remote procedure call. So let's try to access this file. The one way to access it, actually one of the ways to access this file is, first we have to make a open a new directory for just this operation. You can open it wherever you want. I'm gonna open it here and call it mnt, and our command is to transfer this file in our local system is this, and our T flag is for NFC, and then our target's IP address and the file that we want to transfer here, and then the name of the directory for transferring this file, it is mnt, and we will add this parameter too. And then let's go there. Let me make this, by the way, bigger. Okay, I think it's better now. Anyway, let's go there and see our file. So let's try to understand the structure here. The file name is, at the beginning, was home, so there is an cappuccino file under this directory, so we may consider it as a username, because in a normal machine the structure is like that. There is a home directory, and under the home directory there are our users, and these users has a main file which with their usernames, and here we can assume that this cappuccino is a username for a user, for a random user. So anyway, let's go to this cappuccino directory. So when you type ls and press enter, you won't see any file under. So to see the all hidden files, you can use this all flag, a flag, sorry, and by default I also add this L2, and as you can see there are our hidden files here. And there is an interesting file here, which is actually directory here, which is SSH, because as we remember there were 3 open ports and one of them was 22 SSH, and maybe there are some credentials to connect, make a connection via SSH to this target. Right now we are not in this target, but we just copied the file which is shared via NFC, and I wanna add something. From now you can change anything in this file, because you can think like that. If you make a change here, there will be a change also at that server too. So this home file is a common file, is a shared file for the clients for that SSH, for that NFC server. If we make a change here, we make a change in that server. Okay, you will understand better what I mean after a while. So let's go there and discover, is there something interesting? Yes, we have an ID RSI file here. We can use it to connect the server via SSH, because the ID RSI file is like an credentials. It is necessary credentials to make an SSH connection. So let's open a new tab and copy this file to our desktop. Actually, no need to do it, but I'm just gonna see it in an organized way. Copy this ID RSA to this location. Okay, so let's go there, and we said that we will consider this cappuccino as a username. So to make an SSH connection, we most probably need an username, and because we think that this RSI file is belong to a user, and if you try to connect via SSH without a user, it will connect as a root default. So but we don't know we don't know the root's password. Maybe this ID RSI file is belong to the root user, but here it's not the situation, it belongs to the cappuccino user. So to use a ID file, you have to add this flag. Just zoom in, okay, and then the username cappuccino, and then the IP address. Yes, and now we are in, as you can see, now we are in this IP address. Actually, we are in that NFC server. So there are some vulnerabilities right now. Actually, let's check who we are. We are cappuccino. Let's check the system. It's look like Linux. Yes, we are correct, and the host name is NFS. Okay. Here we don't have root permissions, but we wanna do some privilege escalations, right, to have a full access with that target. There are some vulnerabilities in that NFC files, network file system service, and Hacktricks has a good information about that. and we will go follow this way. Actually, here it tells about some vulnerabilities within NFC. Read the SC exports file. If you find some directory that is considered as no root squash, then you can access it from as a client and write inside that directory as if you were the local root of the machine. No root squash, this option basically gives authority to the root user on the client to access files on the NFC server as root, and this can lead to serious security implications. Okay, no old squash, this is similar to no root squash option but applies to non-root users. Imagine you have a shell as nobody user. Actually, we have a shell as cappuccino user right now, but it doesn't make any difference here. And checked HC exports file. No squash option is present. Checked HC passwd file. Emulate a non-root user. Create an SUID file as that user by mounting using NFS. Execute the SUID as nobody user and become different user, which means here we won't become a different user. We will become a root user here. To do that, we have to go back here. What did we say before is we are in cappuccino, and if we make any change here, it also changes this shared too. So as you can see, it is let's go back now. Cappuccino, let's go back to, and we are home. Okay, let's go home, and under the home we have cappuccino. It was on the share and cappuccino, and let's go in the cappuccino. And if I change something here, right now I'm in also, where am I? Okay, if I change here, if I change something here, it will be changed here too. What I mean is here, this. So let's make a change here. Let's try to copy a shell here. Let's start. Right now I'm in my machine, and let's copy the bash here. And when it comes to the permissions, it has to be a little bit different. As you can see right now, we have these privileges to exploit that vulnerability. To leverage that vulnerability, we have to add a SUID UID bit here, and we can do it like that, as you can see. Let's check. Yes, now the SUID bit is added here, and let's keep continue. If you have found this vulnerability, you can exploit it, mounting that directory in a client. Oh, by the way, let's first find that vulnerability. Actually, what we are going to do is check the export file, and as you can see, we have no root squash here, which is the same vulnerability here. No root squash. Okay, and we have this vulnerability right now. No root squash is here as an option. So mounting that directory in a client machine, and as root, copying inside the mounted folder the bin bash binary and giving the SUID rights, and executing from the victim machine that bash binary. And until now everything was okay. Let's exploit it. Let's leverage this vulnerability. Oh, by the way, you can see that also we add a bash file here and change its permissions, and we did it from our machine, but it is also in the cappuccino machine and in the target machine, because the file was shared. So if you make a change there, everything will affect by this change. So we have this file here. We didn't have to copy it, it's just here. Anyway, let's execute it with this flag, because is it's not written here, but sometimes the NFC sometimes the NFC system may confuse about the permissions, so you have to force it. And there was a paragraph about it here, which is it's enumerating. Let's go to exploiting phase, and the P persists the permissions so that it can run as root with SUID, as otherwise bash will sometimes drop the permissions. Here you are better if you use this flag, but it will also work here without this flag too. And now, as you can see, we are still cappuccino. I was wrong actually. It's not working without this flag. As you can see, it's confused. Now it thinks that we are still cappuccino, but we have to be root for it. We did it to become a root user anyway. So let's go back or exit. Now let's force the script to run with sudo permission. And now, as you can see, let's check who we are. We are root, and we did what we want. And after now, it's just about capturing a flag. Let's check who we are. Let's go to the root. LS, and it was all. Thanks for watching. I hope I could teach you something, guys. So take care of yourselves. See you in the next solution videos.